Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over box and whisker plots. Another name for it is called Boxplot, and I'm going to be teaching this in accordance towards the AP Statistics examination. Be aware that this is part of the FASTREV series, and so I cover different concepts and try my best to hit the key points that you need in order to be prepared for the examination. And so when we talk about box and whisker plots, there are some key concepts that you must know, and I'll make sure to go over them step by step. But today, here in front of you is the scenario that I'll be using. So in front of you is the grade point averages for 20 students are listed below. Construct a box plot for this data and describe it. And so I'm going to go ahead and create it by hand, the box and whisker plot. I'm going to explain to you step by step how I got these values and how I'm going to solve it out. And then I'm even going to show you on the TI-84 graphing calculator how to show it on there and in order to ensure that your answers are correct and to confirm that your computations are correct and you didn't make any mistakes. So I'm going to go ahead and get started. So in front of me is a list of these numbers, and the important thing you must always do is that when you're given these type of set of numbers, put them in order. The reason why is that when we're dealing with box and whisker plots or box plots, the property of this examination has it, or this testing has it, that it's best to put these in order before you do anything else. So I'm going to go ahead and do so. So I'm looking for the lowest value. I see 0.8. So I'm going to go ahead and do that for a little bit. So I see 0.8. I'm going to slash that out. Well, so I see 1.6, 1.6. So I see 1.6. So let's put that down. 1.6, 1.6. If I see any values along the way that I miss along the way, I might just insert them along the way and make sure to take them into account. Okay, 1.8. I say 1.8. So I'm going to take them out. Okay. So I see a 1.9, so I'm assuming that's important. Okay. 2.0 is there for certain. Okay, 2.0. Let's see a 2.3. So I'm going to continue and do this. And it does take some time because there are 20 scores on here. There's a faster way to do this on the calculator, but I want to make sure to show you that in case you don't have a calculator or in case that circumstances has it that you just need to do it by hand, then this is the way you're going to go about doing so. So 2.9. Oh, I see another 2.9. Just trying to make sure not to make any mistakes along the way. So 3.1, 3.1. So I'm going to go down here. 3.1, 3.1. So I see 3.1s. I mean, 2 3.1s. 3.2s. I see 2 of them. 3.2, 3.2. Okay. 3.3 I see. Okay. Looks like I didn't mess up yet. 3.6. Okay. And then 4.0, 4.0. Perfect. Okay. So these are the grade point averages of students, and I now have listed them from lowest to highest possible value. And so when I am constructing a box and whisker plot, there's some things I do have to take into account. I do have to take into account that when I'm creating a box and whisker plot, the first thing I need to find is the median. Okay, so I'll write median. So what is the median? The median is the middle number in this set. So when I'm going back and forth on this chart and whatever not, I need to make sure that I am looking for exactly the middle number that exists so that I could go ahead and list it off. So I'm going between 0.8, so I'm going to put dots on top. So I'm going to find the middle number and identify it and show you where it would be. So okay, so going back and forth, yada yada yada, just putting dots so I don't slash out numbers this time. 2.0, 3.1, 2.3, 3.1, 2.4, 2.9. So it's going to be between 2.4 and 2.9. So when instances happen that there's not a clear middle number and it's stuck between two numbers, you're going to find the average between those two numbers. So I'm just going to do it on the calculator real quick. 2.4 plus 2.9 divided by 2. So 2.65. So for this scenario, my median is 2.65. And so what I am going to do actually is create some brackets right here. So I'm going to create brackets here. I'm going to create a bracket here. And I'm going to create a bracket right here. And there is a reason for me for creating these brackets. So when we are constructing a box and whisker plot, it does have a median. There's also a concept called Q1 and Q3 that I must also include in my box plot. Okay, and so what is Q1 and Q3? So Q1, Q3 are the quartile 1 and quartile 3. And what these do is they define the edges of the box plot. So most of the times, if I was to draw you a little sketch of a box plot, it will usually look something like this, where there's this little double box system and whatever not. And so I need to create, this will represent the median and these sides will represent the Q1, Q3. And I'll draw it bigger in a bit, but be aware that I do need these values. And Q1 and Q3 are basically the medians of the lower half and the upper half of this distribution. So by using the median value to split it off, now I'm going to find the median between this set and this set to get Q1 and Q3. So for example, I'm going to just now put a different symbol, let's say little x's on top. So right here, I'm going to do that just for myself to keep track. You could decide to do it your own way. You can use a different color pen. I do recommend that sometimes, just using different colors if you lose track and whatever not. So that being stated, I see it's between 1.8 and 1.9. So between that will be 1.85. So I'm going to go ahead and identify this is my Q1 right here, 1.85. But to continue, for Q3, I got to do the same thing. I got to go back and forth. And make sure that I am able to do this. So it's between 3.2 and 3.2. So between 3.2 and 3.2 is going to be 3.2. So that works out. So Q1, Q3 are going to be these values. Okay, and now this is where it gets a little bit complicated, because on the AP Statistics examination, they do actually require you to also take into account of outliers. So most of the times, in most box plot questions, you're going to assume that there could be a possibility of outliers that exist. And this is how we create outliers, or find out where the outliers exist, if there are any. And so when we're solving for outliers, we need IQR. There's a value called IQR, and it means interquartile range. And to find interquartile range, it will always equal to Q3 minus Q1. So for this scenario right here, that means I'm going to make this Q3 equal to 3.2 minus 1.85, and just punching it once again into my calculator. So 3.2 minus 1.85, and it's going to be 1.35. But I'm not done. That's just the IQR value. To find the values for, for the outliers, you're going to actually do is compute it based on these values. So the lower bound of this thing for outliers, so I'm going to write lower bound outlier, will be, how you're going to solve it is going to be Q1 minus 1.5 times your IQR. This is just an equation you just need to memorize. And for the upper bound, just to make it very clear to you how I'm doing this, upper bound outlier will equal to Q3 plus 1.5 times IQR. And so for this question, just to lay it out and make it very clear for you, it'll be 1.85 minus 1.5 times 1.35, and I'll do that in the calculator soon enough. And Q3, since it's 3.2, plus 1.5 times 1.35. And so on the calculator, it's going to be 1.85 minus 1.5 times 1.35, and it's going to be, it's going to be a very low value, which that means there's no outliers on the bottom I have to be worried about. So 3.2 plus 1.5 times 1.35, it's going to be 5.225, okay? And so once I did the computation, this lets me know that the outliers will start below negative 1.175. So if any student somehow has a negative GPA, which is impossible, but theoretically, if a student had it lower than negative 0.175, that means that there is going to be an outlier. And if a student had a GPA that's above 5.225, that means they are also considered an outlier in this scenario. But considering the fact that my lowest GPA here is 0.8 and my highest GPA is 4.0, I do not have to worry about an outlier for this question. And so for this question, when I'm graphing this out, I do not need to show an outlier. And I'll provide an example just in case on this chart, just to show you what an outlier would look like and how would you label it or make it appear on the chart. But I'll go ahead right now and start creating the Box-and-Whisker plot. So because my values are like this, 1.85, 2.6, 3.2, I think my best sort of intervals for my thing will most likely be 0.5 intervals. It will not give me the exact lineup for the graph, but I could sort of guesstimate and sort of create it so that it will help me just get a general idea. And so I'm going to create a line right here. And this little line is sort of like a number line system to let me create the lines for the Box-and-Whisker plot. So I'm going to go ahead and start labeling. So right here, I see 2. So I do want to put median somewhere like this, 2.5. I'm going to do 3.0, 3.5, 4.0. And of course, it's not the most perfect by any means, the mean intervals. And I'm just drawing it out on purpose, out up to that value. There's no need to go to that point that far, but I'm just doing it just for you guys to reference to. So 0.5 and basically just 0. Okay, and so 2.65 somewhere around here, and I know the spacing is not perfect, but so I'm going to create a line right here, and then so I will label them right afterwards. I see Q1's will be 1.85, so it's around here, and 3.2 somewhere around here, I would say. And so I'm going to create the box parts of this Box-and-Whisker plot, or aka the box plot. And then I'm going to identify my minimum. So the part is this. So when I'm creating the Box-and-Whisker plot, there's not just these little boxes here. There's also whiskers. That's the point idea behind it. And so for this minimum, because I did not identify any possible outliers that exist, my minimum for this question, and I'm going to write it up here, my minimum is going to equal to the lowest possible value that's on my chart, since none of these are outliers, which is 0.8. And my maximum is going to be the highest value on this chart, since there is no outliers once again. So it's going to be 4.0. So 4.0 somewhere around here, I'm going to create a dot, and I'm going to draw my whisker here, and 0.8 somewhere around here, and I'm going to also create my whisker. And that will be how, sort of like a sketch of how it will look like, my Box-and-Whisker plot. So as I mentioned before, this is my median right here. This is my median. This is my Q3, Q1. This is my minimum. Now, in case you want to see this, and this is my maximum. Okay, and so this will be what would it look like, and that will be concluding my sort of explanation or how it looks like to create the Box-and-Whisker plot. But let's say that there is a scenario that somehow there's a super genius in this school and whatever not, took all the AP exams possible in the world, and then suddenly he gets something like a 5.5 GPA, since the highest bound before it's an outlier is 5.225, but let's say he wasn't including the calculations or whatever not, and he has a 5.5, okay? And so right now, let's say there is a 5.5 scenario student, and he is the outlier in this question. The way it's indicated on the chart, usually you'll see it either on printouts or computer printouts or whatever not, it will look sort of like this. It will look like a star. This is what we call the outlier. And what is an outlier is basically someone that's an anomaly from the norm. So that means that the person is just really ridiculously high GPA or low GPA, or like in different scenarios, it might be that the person just has is ridiculously tall compared to the average that exists in the United States. And so those are what we call the outliers in the general population. And so this is how I go about doing it, just, you know, the formal way of, you know, calculating and graphing it out. But now I'm going to go ahead and explain to you how to do it on the calculator. And so when we're doing on the calculator, I always prefer using the TI-84, and I'm going to explain it on the TI-84 how to go about doing so. So on the TI-84, so I'm going to clear everything and whatever not. The first thing you need to do is punch in the data. And the way you go about doing that is that you first push stats, right here, stat button, and I'm going to push 1, which is edit. And then what happens is that it creates this L1, L2, L3 lists. And so I'm just going to use L1 because usually that's the one you're going to be using the most commonly. And I'm going to punch in the values that exist. You don't have to punch them in order. You can punch them in whatever sequence, which will save you a lot of time. So I'm just going to follow the chart right here and just punch them in. 2.0, so there's 3.2. Hopefully I read these correctly. So it looks like a 1.8. Yes, a 1.8. 2.9. 1.9, 4.0, 3.3, 2.9, 3.6, 0.8, 3.1, 2.4, 2.4. Make sure you take your time and make sure you check that you didn't input them weird. Because if you input them weird, your results are going to get affected very severely. So make sure to just take your time and put them in, because you will save a lot of time doing this. So I inputted all the data, and I could tell because I have 20 data sets, and this asked me to input the 21st. So I know I inputted them correctly when it comes to number of numbers. I'm just checking through real quick to make sure that all of them are in decimal format. I'm good. Okay, so that's the first step. Afterwards, now I do want to graph it because I want to see visually in case I might have made mistakes on this chart and whatever not right here, my graph, my handy dandy box and whisker or Boxplot. And so I'm going to go ahead and push second right here. There's a blue button for this calculate second, and then go to the this button y equals 2, or it might be stat plot. And so I'm going to push enter to the first one. I'm going to turn on plot 1. What this does is it lets me now create the different type of graphs. And there are little graphs right here that are shown. So there's a scatter plot that exists, a line, sort of like a linear graph. There's a histogram and whatever not. I'm going to switch it to this one right here in the middle. So I pushed the arrow key back, left and right to get to it once I went down. And so I got it to that portion. Afterwards, I could actually trace it, and it will create my little box plot if you see it right here. Let's say that I don't like that formatting. I don't want to see the XY chart, and this is bothering me a little bit. I want to just see it zoomed up and all that. So I'm going to push zoom then. Actually, not zoom, window, sorry about that, window. And I'm going to change my minimums. So my X minimum right now is at -10. I'll just put 0. And I'm going to make my Y minimum also 0 and push trace. This helps me a lot to just visualize it more closely, and now I can see sort of it's more close. But what's also great about this trace system is that it actually tells me what my median is, which states is 2.65. Confirming from my prior work that I did, median is 2.65. I could push the arrow key, Q1's 1.85, confirm. My minimum value is going to be 0.8, which I found right here, perfect. I'm going to go to Q3. Q3 says it's 3.2, confirm. And my maximum's at 4, which I mentioned right here at maximum equals to 4. And so my graph does align with the graph that the calculator created. And there is no outliers as I mentioned before. So I am perfectly good. The next thing I do want to talk about is sort of how this graph looks like generally, just distribution wise. That's sometimes one of the things that students do get confused or worried about. So a lot of times when we describe graphs and whatever not, there's an acronym that does exist that will help us, do this chart or help us describe scatter plots, or it could be even for other graphs too. So I'm going to go ahead and explain to you, one second, whoop. I'm going to go ahead on a separate piece of paper since I need space. I'm going to go ahead and explain to you what this acronym is. So when we talk about shape, the thing that will help you remember about shapes is that we must describe a few certain things, whether it is based on box plots or anything other else. And I saw this acronym one time on an AP practice exam for one of the students' responses, and they actually used this acronym, SOCS. So it means shape, outlier, center, and spread. So SOCS, basically. And so this acronym really helps because a lot of AP exams, when you're describing the shape and whatever not of a graph, we'll need to hit these 4 points. So shape being that, is it look normal or does it look skewed to the left and right and whatever not? So shape usually talk about if it's normal looking. It could be, not double L, so normal, or is it bell shaped? That's another terminology. Or is it left skew, right skew? For outlier, usually it's what I was talking about before, this little dot. Usually it's when you gotta mention if there is any outliers and whatever not. Center, usually it's talking about either median or mean. And so when we're talking about in the context of box plots, it is going to be us just talking about median. There's no way for us to find mean. And so make sure you do talk about the median value. Spread usually means that is it very spread out like thinly, or is it just clustered and whatever not? So spread out, is it spread out or clustered? But for this type of question, it's very hard for us to tell just because the graph right here doesn't give us exactly a lot of data, like a lot of info, but because we have specific data points, we could talk about how the grades are sort of like just very spread out evenly and such, just because you do have the specific data points as I mentioned before. And so when we're describing specifically this graph, at the very least, to me, it does look pretty normal. It is skewed a little bit, very slightly, and I would, if this did exist, would have to mention the outlier in order to perfectly describe the box plot. But I will also give another example. Let's say that it is severely skewed. okay, and severely skewed to the left. I'll provide a little sketch just for you to be able to see how that would look like. So a lot of times a box plot that does look very skewed will look something like this. I know this might be an exaggeration at times, but there are sometimes graphs that might look like this. This is very skewed to the left, okay? This is skewed to the left. And the main reason why is that the whisker is disproportionately long compared to everything else. And so if it's skewed to the right, that means that the right side will be very long then. But because of this scenario, it is skewed to the left. That means also, technically, when we talk about spread, for example, that means that it is very clustered to the right. All the values will be clustered to the right. Median, we could talk about how the median is a bit higher up towards the general values, and this usually means that there is some sort of bias that does exist in the data. That means that potentially a lot of people that are scoring up here, but if let's say it is in relevance to exam scores, that means that either the exam was too easy or there was some sort of cheating going on, or it could be a lot of different possibilities that do exist, but that means that something's going on here. And so usually it means that there's a huge cluster in median scores and everything is pretty high, yet it's all spread out too. Okay, and so just to be aware of this, this is the general whole breakdown of box plots, or aka box and whisker plots. I did want to cover every single point possible that could be on the AP statistics, whether or not it's just creating the graph, whether or not it's just checking your answers, or even if it's just you being able to describe the graph. And so make sure to review over these concepts. I do have other videos on different concepts, so please do watch these videos. Please do subscribe to our YouTube channel and like our Facebook page so that we can continue to make content like this. I hope you have a wonderful day.